Okay, good day, good people. Um, Let us look at the application. Let us do the application of angular velocity. Right, let's take out the data, the given information. A wheel of a diameter, we are given the data, we are given the diameter, it is 0.6 meters. Let's go ahead and calculate the radius. It will be divided by 2, then it gives us 0.3 meters. Then we are given accelerates from from 1 rev per second to 30. Now we are given n1. This is n1, this is n2. That which indicates for us that this is n1 and n2, the SI unit. It is rev per second. Now, like I said, know the SI units, know the formulas. Now, based on that information, we are given N1, it is 1 rev per second. Let's go ahead and convert it into omega. Omega 1 would be 2 pi n. 2 pi n. It is 2 pi multiplied by 1. Our answer is 6, our answer is 6,283 rad per second. Then omega 2 would be 2 pi multiplied by 30. Then we get our answer as 188,496 rad per second. Right, we've converted n1 and n2 into omega. Like I said, don't assume the n to be what the omega, because they are of different SI units and it is two different. The other one, it is the rotational frequency, and the other one, it is the angular velocity. This is what we have. Now let's look at question number 1. Question A, they want us to calculate the angular acceleration. Now, based on this given information, we must then look for the suitable formula that suits our what? Our given information. And in this case, this formula suits the given what? Information. That's what I said on the first part of this lessons, that you should know your formulas as well. Now, this is the formula that we'll be using to calculate that which they want us to calculate. Now, they want us to calculate angular acceleration. It is linear equals to omega 2 minus omega 1 over time. Do we have omega 2? Yes, we did calculate it. There it is. It is 188,496 minus 6,283 divided by the given time. We are given time. The time, it is 3 seconds. I forgot to write that. It is 3 seconds. Divide by 3. Then our angular acceleration, it is 30. It is 60,737 rad per second squared. Now, another approach to this equation, let's say we didn't convert our n to omega, then you are going to say angular acceleration equals to 2 pi n2 minus 2 pi n1 divided by time. Then you make 2 pi the common factor, then you are having 2 n2 minus n1 over time. Then it is same thing. It is 2 pi open bracket 30 minus 1 divided by 3. Then our answer would be exactly the same, 60,737 rad per second squared. You can take that approach as well, whereby you take out the common factor. Right. Let's look at question number B. They want us to calculate the average angular. Now, in calculating the average angular velocity, it will be angular 1 plus angular velocity 2 divided by 2. We are looking for the average velocity. Then it is 6,283 plus 188,496 divided by 2. Then we get our answer there as 97,389 rad per second. Right. That's how you approach that question, the average angular velocity. Then the third question, they want us to calculate the linear velocity. The fact that they want us to calculate the linear velocity at 3 seconds. Now, that indicates that we are going to use the bridge formulas. This is the formulas that suits the given information. We then have to use these formulas for us to be able to calculate that which they want. The linear. We will then use what? The bridge formulas. But they said in 3 seconds. That means the angular velocity that we need to use. Remember, it is V equals to angular multiplied by radius, and of which we do have the radius, it is 0.3. And the angular that we need to use based on the given information. We will be using omega 2. Now we are having 188,496 multiplied by 0.3. Now let's reread that statement again. Linear velocity at 3 seconds. Now when you go back to the given statement, a wheel of a diameter, it is 0.6 meters, accelerates from, it starts from 0 seconds to 30 rad per, that 30 watt, it was reached at what? 3 seconds. That is why we are going to use omega 2 in calculating what? The linear velocity. Right. Then our answer here, we got our answer as 56,549 meters per second. Right. Because our diameter, it is 0.6 divided by 2, it gives us 0.3. Now, the question number D, they want us to calculate the linear acceleration. They want us to calculate what? Linear acceleration. But here they just said calculate linear acceleration. In calculating the linear, don't forget that we did calculate the angular acceleration. There it is. Now in calculating the linear, it is easy. We are having linear equals to angular multiplied by r. Our linear, it is 60, we did calculate it. It is 60, 737 multiplied by 0.3. Then we get our answer as 18,221 meters per second squared. Right. Then we are done with question number 4. Then question number 5, E. The angular displacement during 3 seconds. Angular, now they want us to calculate angular displacement. In calculating the angular displacement in 3 seconds, it will be angular displacement equals to omega 1 plus omega 2 divided by 2 multiplied by time. This formula here suits the given information. This one suits the given information. That's the formula that we'll be using to calculate that which they want us to calculate. Now omega 1, we did calculate our omega 1. It is 6,283 plus 188,496 divided by 2 multiplied by what? By 3 during 3 seconds. Then we get our answer as 292,169 rad. For number, that was the answer for number E. Then that's how we calculate number E. Then number F. Number F, they want us to calculate the distance traveled by a point on the circumference of the wheel. Now they want us to calculate the distance. Now in calculating the distance, we are going to use the formula of the bridge formula. It is S equals to angular multiplied by R. We do have the angular displacement. It is 292,169 multiplied by 0.3. Then our answer is 87,651 meters. This is how you tackle these questions. You can tell that these questions are easy, good people, when you know the formulas and the SI unit, so as to use the right formula, so as to use the right elements on the right formula, then you are okay. Now the last one, this one, they want us to calculate the number of revolutions after 4 seconds. Now there's 2 ways of doing this question as well, like we did with this one. There are 2 ways. I will show you. The first one that we can use, it is this formula. As we calculated the angular displacement on number E. Now it is 188,496 plus 6,283 divided by 2. Divide by 2, multiply by, instead of multiplying by 3 like we did here, instead of multiplying by what? By 3. I'm looking for that here. Instead of multiplying by what? By 3, we will multiply by what? By 4. Then our answer here would be, as we multiply by what? By 4. We get our answer as we multiply by 4. Let's go ahead and multiply by 4. I got my answer there as 389,558 rad. That's the answer that I got there. Okay, that's the answer that I got there. Now let's go ahead and confirm it here. Right, we are having 188,496 plus 6,283 divided by 2 multiplied by 4. Then it is 389,558 rad. Exactly. That's the correct answer. Remember, don't forget that they are looking for what? They are looking for number of revolutions. Now we managed to calculate the number of revolutions. Then we managed to calculate the theta, then we can use this formula 2 pi n and make n the subject of the formula. It will be theta divided by 2 pi. Then it is 389,558 divided by 2 pi. Then you get your answer as what? I got my answer as 62 revs per second. No ways, not rev per second. It is 62 rev, because we are looking for number of revolutions. The N here, it is the N for revolutions. Now, another approach that you can take in tackling this question, you can say N equals to, calculate the average N. You can say N equals to N1 plus N2 divided by 2 multiplied by 4, or rather multiplied by time. Remember, it is the same formula. We took out what the common factor there, and the common factor, it is 2 pi n. Then you are having 1 plus 31 divided by 2 multiplied by 4. Then it will be 30. This is 30, not 31. It will be 31 divided by 2 multiplied by 4. 31 divided by 2 multiplied by 4. You will get your answer as 62. Now let's do it step by step. It is 31 divided by 2. Then you get 15,5. This is a rev per second multiplied by 4 seconds. Now this, it is one and the same thing as 15,5 rev per second multiplied by 4 seconds. Bases are the same. What do we do with exponents? We add them. Anything to the power 0 equals to 1, then you'll be left with what? 15,5 multiplied by 4, then it gives us 62 revs. That's another approach that you can take to that equation. This is how you tackle these questions, good people. This is how you tackle this question, good people. Now let us look at the last application. Let's take out the data, the given information. A turbine at the plant with the diameter of, we are given the diameter, take out the data. We are given the diameter, it is 0.8 meters. Radius would be divided by 2, then it will be 0.4 meters. Right. Rotating at 600 rad per second. Now we are given omega 1, it is 600 rad per second. What indicated to me, it is the SI unit. Rad per second, it is omega. Yeah? Rotating at slows down 2. Then omega 2, it is given as what? As 400 rad per second. Time, it is given as 30 seconds there. Now, you can either be given questions. Now, I showed you 2, if not 3 questions with different SI units. But the fact that we understand the SI unit, we are not using the given information into wrong things. Based on the SI units, we are able to use the given information into the right elements and formulas. Now, question number 1, they want us to determine the angular acceleration. Angular acceleration would be omega 2 minus omega 1 divided by time. There's no need for us to calculate the omegas. They are given. Omega 2, it is 400 minus omega 1, it is 600. You can tell that this turbine, it is experiencing what? The retardation, the reduction of speed, right? Divide by what? By 30. Then we get our answer as 400 minus 600, that would be negative 2, divided by 30. Then we get our answer as negative 6,667 rad per second squared. That was question number 1. Then question number 2, determine angular displacement of the turbine. In calculating the angular displacement, we know that angular displacement equals to, angular displacement theta equals to omega 2 plus omega 1 divided by 2 multiplied by what? By t. Because these formulas, they suit the given information. We are given 600 plus 400, that would be 1,000, divide by 2, multiply by 30, then we get our angular displacement. We got our angular displacement as 15,000 rad. 15,000 rad. That's what we got there as our answer. 15,000 rad. Determine angular displacement of the turbine in radians. That's what we did there. Then question number 3. Question number 3, determine the number of revolutions completed by the turbine during the slowing down. Now the fact that we've calculated there, they want us to calculate, it will be angular displacement 2 pi n. They want us to calculate n, it will be theta divided by 2 pi. Then it is 15,000 divided by 2 pi. Then our answer would be it is 2,387,324 rev. Boom. This is how you tackle these questions, good people. Angular motion, it is easy, straight to the point, because it is one and the same thing as linear motion. The other one occurs on the horizontal straight line, the other one occurs on the angular, on the circular course. That's where the difference is, but it is the same concept and it uses same things. The difference, it is the change in symbols regarding the variables and all that. Thank you, good people.